Hey everybody. Today's lesson is going to be a little bit of beginning algebra, and I'm hoping for some of you this is a review, but if it is, the review is also good. So the two topics we're going to look at are combining like terms and solving for variables, and as you can see, if you read through the target, you will be using combining like terms and solving for variables in Thursday's lesson, where we'll actually use this to determine the measurement of missing angles. Okay? One way I like to show this is with objects. All right, so I'm just, tried to find something I could find pictures of online. So I'm like, well, what about apples and bananas? It's perfect. So I found two pictures of apples and bananas here. And as you can see, there are 4 apples and 2 bananas in the picture on the left, and 1 apple and 1 banana on the picture on the right. So in algebra, we use variables to represent various objects. In this case, I'm going to use an obvious one. I'm going to use A for apples and B for bananas. So you can see if we're writing this algebraically, this is what this looks like. We've created an algebraic expression to represent this picture. All right, so the one on the left is 4 apples plus 2 bananas, or we would write it as 4A plus 2B. And on the right, it's 1 apple plus 1 banana. You might be asking yourself, well, why isn't there a 1 in front of the A and a 1 in front of the B? Good question. In algebra, though, if there's just one of the objects, we don't bother to write the 1 in front of it. It's just assumed that if it's by itself, there's only one of them. So it becomes unnecessary to write that 1. In fact, as you get into algebra a little bit further, if someone were to write 1A, of course you would know what that means, but it would look very strange to you, right? Well, let's take a look then at how we would write the total. What we would do is we would combine things. This is combining like terms. Think about it as we're combining like fruits, all right? It's the same thing. We have a total of 5 apples and 3 bananas. We combine the 4 apples from the left with the 1 apple on the right and got 5 apples, and we combine the 2 bananas on the left and the 1 banana on the right to get 3 bananas. Now the thing is, since bananas and apples aren't like fruits, we can't combine them any further. That's the best we can do, right? Because we're making it clear we've got apples and bananas here. In algebra, combining like terms is very similar to that. In algebra, your like terms have to be the same variable to the same power. So let's take a look first at the picture on the left, where it says like terms and unlike terms. Right? This expression right here, 2x squared plus 3x minus 5, has 3 terms. In algebra, terms are separated by addition and subtraction symbols, so that's why we have 3. And you can see they're all different. None of them are to the same variable to the same power. But if you look over here on the right, this expression has 4 terms. The 2a squared plus the 3a squared, those are like terms. So if we wanted to, we could simplify that by combining these two to make it 5a squared plus 7a minus 7. Well, let's take a look at this. Why does it have to be to the same power? All right, well, let's say x equals 3. Then what does x squared equal? Yeah, x squared equals 9. So then x and x squared are not the same value. We can only combine things if we know they are the same value. So that's why we have to have variables be to the same power. All right, so let's try a few examples here. And you can see on your guided sheet, I want you to try these on your own, right? And then I want you to check them with the next slide. Pause if you need to. All right, so you can see in this case, the correct answer is 9x plus 2y plus 6x plus 10y equals 15x plus 12y. Right, we combined the 9x and the 6x because those are the same variable to the same power. Here we are here. and then we combined the 2y and the 10y, getting 12y. Okay. How about this one? This time I have some subtraction in here. So think about this as if somebody ate the apples and bananas. It's like that. So I've got 9x minus 2y minus 6x plus 10y. By the way, you can also think about this as a negative 2y and a negative 6x. More about that later, but I just wanted to give you that little tidbit. All right, so when you combine them, you can think about it as 9x minus 6x, so that's going to be 3x. And you've got a negative 10y, a negative 2y and a positive 10y, which gives you an 8y. Did you hear how I said that two different ways? This time I said it as 9x minus 6x. And this time I said it's negative 2y plus 10y. It doesn't really matter. That's really the same sort of thing. I could have also said 9x combined with a negative 6x. That gives you positive 3x. And I could have done it this way. 10y minus 2y gives you 8y. I prefer that people think about these as negatives and positives. I'll be getting more into that later, and I'll get more into why it's better to think about them as negatives and positives. But hopefully that made sense. All right, what about this one? This time we have some x squareds, we have some x's, and we have just some what we would call constants. A constant means it's a term with no variables in it. It's always the same number. It's a constant. It never changes. All right, here's the answer here. Okay, you've got 5x squared minus 5x plus 2. Again, you could think about that as a positive 5x squared. You could think about this as a negative 5x, and that is a positive 2. All right, so we got the 5x squared by doing 9x squared combined with negative 4x squared. We got the negative x by doing this. We have positive 3x and negative 8x. That gives you negative 5. And then we have a negative 5 and a positive 7. That gives you a positive 2. I bet you can already hear why I prefer negatives and positives in these types of things. All right, the second target for today is to work on a little bit about solving equations. When we have an equation with just one variable in it, we can figure out what that variable equals. So think about this problem here. If I have the equation x plus 7 equals 15, what does x have to equal? Yes, it has to equal 8. All right, so how did you figure that out? I have that on your paper, so I'd like you to write that down for me, how you figured out it was 8, if you figured out it was 8. But what I'd like to show you is what we do in algebra. All right, when we have an equation with just one variable, here's what we do. We do something called isolating the variable. Okay, so if you think about the term isolate or isolation, that means when something is left alone. So right here, here's how we do it. We want to leave the x alone. It's like, well, how do we do that? Well, since we have x plus 7, what we could do is subtract 7 from this side. But whatever you do to one side of the equation, you must do to the other in order to keep both sides equal. So if I'm going to subtract 7 from this side, I need to do the same here. So this leaves me on this side with x and this side with 8. So by subtracting 7 from both sides, it equals 8. Right, you might not have had to do that because you might have been able to do that in your head, but this becomes very useful when it gets a little more challenging. So let's say I had x plus 678 equals 945. Well, I can isolate the variable x by subtracting 678 from both sides. When I do this, this goes away because it becomes 0. So it leaves me with x. On this side, 945 minus 678 equals 267. Right, now I'd like to have you check your answers to be sure. So what I'm going to do is substitute this 267 in for x, and I'm going to see if it works. So instead of x plus 678, I'm going to put in 267 plus 678. When I do that, it equals 945. Yes, that's what I was looking for. So I have the right variable. All right, here's another one. Let's say you have a subtraction problem. Again, you could also think about that as a negative, all right? But let's think about it as subtraction first. In order to basically leave the variable by itself, we need to do the opposite of what's happening here. So often I tell students, when you're solving for variables, think opposites, right? We're doing the opposite of what the problem is doing. Right, so we added 77 to both sides, and when I do this, I have x is equal to 133. You could also think about this as a negative 77, and then you're going to combine it with a positive 77. Note, we're still talking about opposites here. Same answer, of course. All right, so I'm going to double check it. I'm going to plug my 133 in where x is. So down here I have 133 minus 77, and when I solve that, I get 56. Yeah, that's what I wanted. Okay. The same holds true for multiplication problems. Right? Remember, when the number is next to the variable, it means to multiply. So if 2 times x is equal to 14, what does x have to be? Yeah, you got it. It's 7. Now again, you probably could have done that in your head, but in algebra, what we do is we divide. Again, think opposites. This is multiplication. The opposite of multiplication is division. In this case, we're going to divide by exactly what's with the variable because we want to be left with 1. Remember earlier in this video, I said if there's a variable listed by itself, it's the same as having a 1 in front of it. So what we want is a 1x, which is just x. So you divide by whatever is with the variable. And again, you have to do the same thing to both sides. Right, when we check this one, we can see 2 times 7 is 14. So we've got the correct answer. Here's one that's a little more challenging. All right, I have negative 45y equals 720. Again, reminder, you want to divide by exactly what's with the variable. Why? Well, you want to be left with a positive 1. Right, again, I've got my cursor as if it's there. To get a positive, you have to do a negative divided by a negative. So if you just remember to always divide by exactly what's with the variable, you'll get the right answer. Right? Then I have 720 divided by negative 45. That gives me negative 16. So here is what my variable equals. Here's my check, and sure enough, it worked. Okay, so quick recap. We started by combining like terms. All right, here's an example of that. Combining 6a and negative 4a gives you 2a. 7b and negative 3b gives you 4b. Then we just did some work on solving for variables. And here's an example right here. 24f equals 840. Divide both sides by 24. Whoops, and you have f equals 35. All right, sorry about covering that up there. All right, there we go. All right, now, the reason I just did the recap is sometimes we need to do both. If that's the case, make sure to combine like terms first. So if you take a look at this example, 6x plus 7 minus 2x plus 8 equals 343, you start by combining like terms. All right, now, you have to do this on separate sides of the equation. Note, I did not try to combine the 343 with the 7 and the 8. All right, you have to keep them separate. All right, so on the left-hand side of the equation now, I have 4x plus 15 equals 343. Now you solve for the variable. All right, so this is the next thing about this last problem. This has 2 steps. Right, if that's the case, save your division step for last. All right, so you start by getting the variable on one side, the number on the other, and we do that by subtracting 15. So in this case, we're left with 4x equals 328. And then you do what you know to do, right? You divide. So we divide both sides by 4, and we're left with x equals 82. Then you can see right here on the right, I'm checking it. 4 times 82 plus 15. Right, well, you do your multiplication first, order of operations. So that's 328. That should look familiar. Plus 15 is 343. It works. All right, nice job today.